Hi, this is guidance for Criterion E Strand 1, in which you will redesign your prototype so that it might be a viable commercially produced product. Strand 1 involves you developing your prototype design to address the required modifications for a commercially viable production process. As part of Criterion D, you suggested improvements to your design following the evaluation of its success. You should incorporate these suggested improvements into the redesign of your prototype and into a product that can be manufactured using commercially viable production processes. However, it's very important to note that Criterion E must solely focus on the redesign of the product to be commercially manufactured. Any improvements that you suggested from Criterion D that do not involve the redesign of the product to be commercially manufactured should be ignored. As you redesign your product, you need to consider aspects that affect the design, including those listed as part of Criterion F, which is the choice of materials, components, manufacturing techniques, and scales and volumes of production. Criterion E and Criterion F need to be addressed concurrently. That means you need to keep Criterion F in mind as you're working on Criterion E. The scale and volume of production will limit the choice of manufacturing technique and materials used, and this, in turn, will affect the way that the product needs to be redesigned. So, for example, if you're planning to use something like an extrusion, like plastic extrusion, then you need to be thinking to yourself, okay, what kinds of plastics can I use? So it's really important that you're keeping those kinds of things in mind as you're redesigning your prototype. As part of Criterion F, students are expected to carry out additional research into commercially viable production processes and can consider which of these are appropriate for the product. The research will inform the redesign of the product. Students need to be aware that they do not need to include all of their research or raw data, but should just annotate the key findings from each additional research that they undertake that contributes to the development of their idea. Just like in Criterion B, when you're redesigning your product for commercial viability, you should be using appropriate techniques for redesigning the product. That could be freehand sketching, formal drawing technique, computer-aided design, modeling, testing, and experimentation. You should include evidence of how you have changed your design of your product to suit the selected manufacturing techniques. Modifications of the design of the product is ultimately focused on lean production and ensuring the production is cost effective. You can do this by reducing the number of components, standardizing components for use in a product family, using standard components to be brought in, reducing the number of processes, considering the use of molds or jigs or computer-aided manufacturing, redesigning components to make suitable for being made into molding processes. For example, consider drawing angles, spurs, and flashlights. Using automated or low-skill processes, speeding up assembly during production, making assembly for the user intuitive if necessary, considering the recycling of parts at disposal stages for the user, and wastage considerations for material. Use nesting to reduce waste or calculate percentages, things like that. The changes you make to your product should be presented using appropriate techniques and annotations. You should ensure that all images are of good quality and that the scanned or photographed images are clearly visible on the screen. You need to be aware that you may need to adjust the brightness or contrast where necessary to ensure that all of the images can be seen in their entirety. When annotating drawings and diagrams, you need to articulate your design thinking by highlighting the key features of an idea and the developments made to the design. The why was the change made to the design, and reference design specifications as a means of driving the design development. You should focus on including annotations on meaningful decisions made that demonstrate how the design of the product has changed to become appropriate for the selected manufacturing process that you're going to detail in Criterion F. Just like all other annotations, you must make them legible and concise using appropriate terminology and conventions. This section should only include annotations of 10 words or fewer. Extended writing to explain ideas or narrate the concept development must not be used. If annotations of more than 10 words or extended text is used, it will contribute to the overall word count. This is an example of a high performance on Criterion E Strand 1. Recommendations for a commercially viable injection molding production process indicate that the student has a thorough understanding of volume for production process. There is evidence of significant changes to the product to those identified for Criterion D for a one-off production, which take into account the design for manufacturing and assembly when scaling up to production process. Some consideration is given to the change of materials and production processes while still retaining the functionality of the design. The use of mold flow analysis indicates a highly competent analysis of data and the need for a complex mold with 3 injection gates. Modifications made to tubing suggest an incorrect process for creating holes and radius needed for the bending of the tube to 90 degrees. This is also an example of a high performance on Criterion E Strand 1. The student demonstrates a sound understanding of commercial manufacturing processes and the requirements related to injection molding for the product. The need to change the wall thickness to avoid heat shrinkage, add ribs, and include draft angles indicates a thorough command of concepts and principles. The use of mold flow analysis indicates highly competent analysis of data. Further changes to the mold were needed to eliminate areas where low-quality injection molding is identified. Changes to electronic internal components are not considered. Modification for commercial manufacture should be considered for all aspects of the product. This is an example of a medium performance on Criterion E Strand 1. Some overlap of evaluation for Criterion D is included. Some of the modifications were general improvements to the design rather than specifically for commercial manufacture. For example, change 1 in setback, changing the height of the back seat, and change 4 in dimensions, changing the overall dimensions of the product. These change the product but are not specific for commercial manufacture, which is important for Criterion E. Some recommendations are for a one-off product instead of those needed for a commercially viable production process. It is important for students to consider how the product can be standardized for repeated manufacture, focusing on maintaining the same quality and characteristics through a batch of products. Some consideration is given to the change of machinery needed to create the product, but the size of the mold and complexity of machining from aluminum would need to be a factor in potential market size to ensure the costs are viable. This is one area where it is important for students to develop their work for Criterion E and Criterion F concurrently. The shape of the components potentially creates a huge amount of waste, which will significantly increase the cost of manufacturing and environmental impact. When thinking about the use of computer numeric control, CNC machining, the student should have considered nesting parts to reduce wastage. This is an example of a low performance on Criterion E Strand 1. The student attempts to develop the design for a commercially viable production process, but the design is not developed for the anticipated process of manufacturing identified, that is, thermal forming or vacuum forming. Considerations of draft angles, rounded edges, vent holes, and trimming are needed. There is limited evidence of work to support the design for a commercially viable production process. It is important for the student to recognize the need to engage in meaningful design development focused on commercial manufacturing. This includes sketching, modeling, gathering feedback, and refining the design.